Okay, so standard form is another way that we can be given the equation of a line. So standard form is ax plus by equals c. A, b, and c are numbers. So if you look down here, 4x minus 5y equals 20. So that's our a, our b, and our c. There are two methods that we can use to graph standard form. Both of them, I think, end up being about an equal amount of work. It just depends on which one you prefer, but truly they end up being an equal amount of work. It just depends on whether you like solving things or converting things, basically. So the first method that we are going to learn is the converting method, and the converting method is us taking this equation and solving for y. We're doing we're making it y equals mx plus b. So this is essentially the same thing we did in 1.8 when I gave you an equation and you just rearranged all the letters. That's what we're doing here. We are solving for y. So go ahead and open up this first flap, the 4x minus 5y equals 20, and we'll do that work right here, and then we'll graph it right here. So open up your top left flap. Okay, so 4x minus 5y equals 20. We are trying to get y by itself. So the first thing that we need to do to get y by itself is get rid of that 4x. So we still just use opposite operations. We are going to subtract 4x from both sides. On the left side of my equation, I have a negative 5y. And then on the right side of my equation, I have 20 minus 4x. But since I want this to be in y equals mx plus b form, instead of putting the x last, I'm going to actually put it first. So instead of writing 20 minus 4x, I'm going to write minus 4x plus 20. So I'm always going to put it in that order, because that's always the order that I'm going to want it to be in a moment. Alright, from there, to get y by itself, I need to get rid of this negative 5. That is currently multiplication. Opposite of multiplication is division. So I'm going to divide by negative 5 everywhere. I'm going to divide by negative 5 here. And then I need to do it on the right side of my equation in both of these places. So I'm going to divide by negative 5 here and here. Okay, these cancel out, so I just have y equals. And then we have to do some simplification. So right here, negative 4 over negative 5. A negative divided by a negative becomes positive. So instead of negative 4 over negative 5, we're going to make that just positive 4 over 5. And we still have our x. And then 20 divided by negative 5 is negative 4. Okay, any questions on the converting? So it's two steps. We subtract over our x term. We divide by the number that's in front of y. So then we have a slope and a y-intercept. Our slope is 4/5. Our y-intercept's negative 4. We go on our graph to negative 4. Find our ruler. We graph a slope of up 4, right 5. And I can only fit one dot, and I can't fit any the other way either. So there will be several times today you will only have 2 dots, and that's okay. If you have the option to do more, you should. But if you don't, it's fine. Okay, any questions about that problem? Okay, then go to the one right below that. We're going to do one more in this same method. So the last one that we're going to do with the converting method is this x plus 4y equals negative 4. hold this down with. There we go. So the first thing that I'm going to do is I'm going to put an imaginary 1 in front of my x. Because I'm going to want that there. So when I have to deal with my fraction, it's going to make my life easier. And then it's the same 2 steps. I'm going to subtract over the x term. I'm going to divide by the number in front of y. So I'm going to subtract 1x. I've got 4y on the left equals. On the right side, I've got negative 1x minus 4. And I'm going to put it in that order. Okay, what do I need to do to get y by itself? Divide by 4. So I need to divide by 4 to get y by itself. So I divide by 4 everywhere. So I get y equals, this is going to stay negative 1 over 4 x. And then negative 4 divided by 4 is negative 1. So negative 1/4 x minus 1. So on our graph, we'll go to negative 1. Oh, sorry, I should probably write down my slope here. Negative 1/4, negative 1. So we'll go to negative 1, and then my slope is negative 1/4, so I go down 1, right 4. And then to get another point there, I can also go up 1, left 4. Okay, any questions right now about the converting method? Okay, the only thing I will say, let's say we convert and we get 2 over 4. We would want to reduce that 2 over 4 to 1/2. Let's say we get 10 over 5. We would want to divide out that 10 divided by 5. 10 divided by 5 is just 2. So if you can simplify whatever your slope ends up being, go ahead and simplify it. I don't think that happens a ton on the assignment if you choose to convert. Let me look. Let me look. Doesn't happen there, doesn't happen there. There's one place where it's 3 over negative 3. What's 3 divided by negative 3? Negative 1. So you would just simplify that to negative 1. And there's another place where it's negative 2 divided by negative 2. Negative 2 divided by negative 2 is positive 1. I think those are the only places. So, that's all. If you can simplify things, you can. You should, though. Hey, let's look at our other method then. So our other method is called the intercepts method. So far, the only intercept we've dealt with has been our y-intercept. With slope-intercept form, we've always started our graph on our y-intercept. So our y-intercept is where we cross the y-axis. We also might have an x-intercept, which is where we cross the x-axis. So the intercepts method is us finding both of our intercepts. So our x-intercept happens on the x-axis. Every single point along the x-axis has a y value of 0. So to find our x-intercept, we are going to plug in 0 for y. Alternatively, to find your y-intercept, you plug in 0 for x, because every single point along the y-axis has an x value of 0. So if I were to graph anywhere on a coordinate plane, on one of my axes, show this to you so you can visualize it. If I can grab a coordinate plane from back here. Oh my gosh. So on my x-axis, now I need to find a marker. This is the point 2, 0. This is the point 6, 0. This is the point negative 6, 0. All of those have a y value of 0. On my y-axis, this is the point 0, 4, 0, 1, 0, negative 4. All of those have an x value of 0. So because we know that points along the axes have either an x value of 0 if they're on the y-axis or a y value of 0 if they're on the x-axis, we can just plug in 0 for x or y and figure out what our intercept is going to be. So, open this up. The first problem we've got here is 3x plus 4y equals 12. This first example that we do, I'm going to write down a lot of steps, and then I'll show you that you don't actually have to write that down. But I want you to have in your notes written down one time what you need to do. So I'm going to draw a line right here. Thank you. And then grab this. So I'm going to write down right here that we're finding our x-intercept. And we're going to do that by plugging in 0 for y. So plug in 0 for y. So what that's going to look like is 3x still plus, instead of 4y, we're going to do 4 times 0 equals 12. What's 4 times 0? 0. So now we have 3x plus 0 equals 12. And adding 0 doesn't do anything for me. So 3x plus 0 is just 3x. So this is just 3x equals 12. We'll divide both sides by 3. And we will get x equals 4. So what that means is that our x-intercept is at the ordered pair 4, 0, because we got 4 for our x value, and then we had already plugged in 0 for our y value. So our x-intercept is 4, 0. So we can go ahead and write that down on our line right here, 4, 0. And then we can go ahead and graph it on our graph. Our x-intercept is 4, 0. Right. From there, we're going to do the exact same thing with the y-intercept, and then the next example, we're not going to write nearly this much. But I want you to know in your notes what you're doing. So to find our y-intercept, you need to plug in 0 for x. Plug in 0 for x. Okay, so we'll do 3 times 0, because we're plugging in 0 for x, plus 4y equals 12. Three times 0 is 0. We got 0 plus 4y equals 12. Zero plus 4y is just 4y. So it's just 4y equals 12. And then we divide by 4 on both sides. And we get y equals 3. Meaning our y-intercept, we had plugged in 0 for x. So our x value is 0, our y value is 3. So it'll be 0, 3. 0 over, 3 up. 0, 3. And then graph it 0 over 3 up. So for these ones, you're just going to have 1 point along the x-axis somewhere, 1 point along the y-axis somewhere, and then you're just going to connect those 2 points. Use a ruler, though, and go all the way across your graph. Okay, so this was a lot of writing. We do not need to write that much. I wanted you to write that down on that one so that when you look back, you know where in the world the other term went. But to show your work for these, we really just need to do this part down. Because we can know if we're going to plug in 0 for y, it's just going to 0 itself out. So we don't need to show plugging it in, zeroing it out, eliminating it. We can just know that it's going to eliminate by itself. Okay? Any questions right now before we do one more with way less work? Okay, so let's move to this next one. This next one, once again, we're going to write down x-intercept, y-intercept. To find our x-intercept, we're just plugging in 0 for y. So I'm just going to eliminate that entire term, because I know minus 6 times 0 is just going to be 0. So I'm just going to solve 3x equals negative 18. I solve that. So I divide by 3, and I get x equals negative 6, which means my x-intercept is negative 6, 0. Graph that on my graph. I'll go left 6, up 0. Alternatively, my y-intercept, we're just going to eliminate the 3x because we would do 3 times 0. That 6 is still negative, though. So this is going to be minus 6y, or negative 6y, equals negative 18. And then we'll just solve from there. So we'll divide both sides by negative 6. We'll get y equals 3. Because a negative divided by a negative is positive. So that means our y-intercept is 0, 3. So it'll be 0 over 3 up. Okay. And then you can once again just connect both of those. Okay. Any questions on intercepts method? Okay, this should fit perfectly in your notebook. So in your notebook, you can just, after your 2.7s, or 2.6s, this is 2.7, you could just stick this right here. Fits perfectly. By the time you fold in those flaps, it's its own page. All right, I'm going to go ahead and stop the video. Bye, video.